Hello everyone, my name is Sajay Kumar Maurya. Good afternoon and good evening and good morning. I am excited to present my research on the comparative evaluation of recommendation system engine for the media platform. This study delves into the integrate mechanism of recommendation system which are pivotal in shaping user experiences on the media platform. Over the course of this presentation, I will explore the various engines powering these systems, evaluate their performance, and discuss their implications for media consumption. Let's begin by understanding the fundamental aspects of recommendation system and their significance in today's digital landscape. Before diving into the detail, let me outline the structure of my presentation. This will provide the clear roadmap of what to expect. First, this problem statement. I will begin by identifying the key challenges and gaps on the current landscape in recommendation system. Significance of study, and next I'll discuss why research is important and what is the significance. Data gathering and how we can gather the data, what are the sources which we can look and collect the data for this study. Literature reviews. These sections will cover the existing research and theories that form the foundations of my work. Research methodology. Here I will be detailed about the approach and techniques employed to evaluate the recommendation system. Exploring the data, I'll present about the analysis, data collected, and highlight the key insight. Research and evaluations. These sections will showcase the finding of study, their implications, and conclusion. This will be the important steps to summarize the key and takeaway from this research. Future scope. Finally, this is the point to discuss about the potential areas and future scopes and improvement. And last, not the least, I will be conclude by acknowledging the sources and studies to inform the research. This research. First, problem statement. The problem statements for the digital age, the media platform such as Netflix, Spotify, YouTube play a central role in content consumption. However, these platforms face significant challenges in recommending relevant content to users. The key issues includes the cold start problem, where the new users and items lack sufficient data of accurate and recommendation, scalabilities, platform grow and uh, uh, and handle the massive data sets uh, changing users, and which requires system to adapt dynamically, and traditionally recommendation methods often fail short in engaging the new users promotion and diverse content, leading to the suboptimal user experiences. To address these challenges, this research explored the potentials of deep learning techniques to enhance the recommendation system. The primary objective of investigate compared the effectiveness of three advanced recommendation methods like matrix factorizations, autoencoder, and hybrid collaborative filters. By evaluating these techniques, the study aims to improve the accuracy, scalability, and adaptability of media recommendations, ultimately enhancing the user satisfaction and the platform performance. The research is motivated by the need to bridge the gap between the traditional methods and evolving the demand of the media landscape. Let's now move to the significance of this study. Significance of this study, basically, to this research to hold the substantial importance of both media platform and their users. First, enhance user diversity, improve the recommendation system directly to contribute to higher user engagement by increasing watch time and increasing to user engagement and explorations of new genres. This not only benefit to users by exposing to them to wider range of the content, but also it support creators and platform by expanding the reach diversity of their offerings. Second, measurables success matrix to effectiveness of the recommendation system is evaluated using the key metrics such as engagement rate, satisfaction score, precision, normalized discounted cumulative gains, and diversity metrics. These metrics ensure that recommendations are not only accurate and well ranked but also encourage users to explore the broad spectrum. And third, mitigating the filter bubbles. Advanced models such as hypercolourability mod filters play a crucial role into the introducing diverse recommendation system by helping the user to discover variety of contents while maintaining the relevance. These models enhance user satisfaction and improve the platform retention rate. And finally, ethical considerations and responsible practices, and these research also addresses the critical ethical concern such as privacy and user autonomy by promoting responsible data usage and ensuring the recommendation system enhance the user choices. And the study uh, aim to strike and balance between the business goal and ethical standards, fostering trust between the platform and their user. In summary, this research is not only advanced technical capability of recommendation system but also address the practical and ethical challenges, making it significant contribution to the fields. Next, I'll discuss about data gathering, which form the backbone of the research. For this study to utilize the movie recommendation system data set, data we gathered from the Kaggle, which is a well-known portals which has a millions data for the data science and the machine learning resources. This data science was chosen for its comprehensiveness and reliability to ensure that our analysis is built on solid foundation. This dataset companies comprises with 62,400 movies and 25 million users are rating, making their extensive their diverse collecting data. It is structured in two main tables. First, movie tables. Second, rating tables, which contains the movie ID, titles, genres in the movie tables, and rating tables has user ID, movie ID and ratings and timestamp. This rich database supports to collaborative filters, content-based recommendation methods, and provide the ample data of trainings and evaluating the deep learning model, which includes the user interactions alongside movie metadata allows to implement advanced recommendations assist techniques such as hybrid model, which combine the strengths of multiple approaches. The scale of diversity of the data set are critical for developing accurate and scalable recommendation system. By leveraging the data, we are able to experiment experiment with the various deep learning architectures such as autoencoder metric factorizations to enhance their personalizations and system performance. In the next section, we'll talk about literature reviews, which provides the theoretical foundations for this research. Over the years, significant advancements have been made in the field of recommendation system, particularly in the context of media platform. One notable contributions come from the Sharma Yadav 2020, who have developed who have developed and bringing the uh, enhancement. These slides improve the innovations approach in the recommendation system alongside algorithm, and their contributions in the field of significant contributions comes from Aljavi Kalyani in 2020 also, who introduced the biliga and genetic algorithm based system. This approach enhanced the recommendation accuracy by opting the entire recommendations list using the both semantics and rating data, and their work demonstrate the potential of evaluationary algorithm to improve their precision and relevance of the recommendation. Another notable study was done by Ficker, Ficker et al. 2020 focus on improving the collaborative filters through the enhanced triangle similarity measure. By refining the similarity calculations and achieved lower the mean absolute errors, root mean square errors, all the data sets like film trust and movie lens. This advancement highlight the importance of robust similarity metrics to enhance the recommendation precision. Further, CK and Srikantia's 2021 evaluated the various similarities metrics in calibrating filters, uh, particularly in the movie lens data set. They have found the item based methods were more accurate and computationally efficient, but noted the challenge with the small lens data set. Their findings underscore the needs of adaptable algorithms that can be handled diverse data conditions. In addition, Pandakis et al. 2022 reviewed the evaluations, collaborations, filtering, and emphasizing that role deep neural networks and autoencoders, with the highlights of growing shift reward towards the incorporating serendipity or diversity in recommendation, moving beyond the more accuracy to enhance the satisfactions of. Lastly, Nagion et al. 2020 introduced the cognitive similarity based collaborative filter method, which improved recommendation accuracy by 11% using the three-layer architectures and crowdsourced data. Meanwhile, Fayaz et al. 2020 explore the recommendation challenges across the domain like e-commerce, healthcare, and agriculture, and agriculture, advocating the hybrid model to address issues such as the cold start problem and scalabilities. And these studies collectively demonstrated the rapid evaluations and recommendation system driven by innovations algorithm, advanced similarity, and metrics. The cross-domain applications are research built on these foundations to explore the effectiveness of deep learning based approaches in media platform. Research methodology. This is a very important topic in the research proposal and research method final thesis, which outline the systematic approach we followed to achieve the objective of this study. And the methodology is divided into two key steps. First is business business understanding and data and business understanding and data scientist. So business understanding is primarily goal of this research is to design and evaluate the recommendation model tailored in for media platform. We aim to address the critical challenges such as cold start problem, scalability, dynamic users preferences. By enhancing the accuracy and personalization of recommendations, this recommendation This study seeks to improve the user engagement and overall the performance of the system. Importantly, the approach ensures the recommendations are not only theoretically sound but also the practically aligned with the real world problem. And second, as I mentioned, that is called data utilization. To achieve this objective, we utilize Kaggle movie recommendation system data set, which is robust and comprehensive resources. This data set includes over 25 million users ratings and 62,400 movie. In it features two main components and user item interactions. It has two main components. One is user item interactions such as rating, timestamps, users, which are ratings, the essential collaboration filters, and item metadata. This includes the title of genres and which supports the content based and hybrid recommendation approach. This data set provide a solid foundation of implementing and evaluating the various recommendation techniques, including collaborating filtering and content based method hybrid model. By leveraging this data, we are able to train, test, and deep learning models, ensuring that finding are both accurate and scalable. Next, research methodology. We break into the uh, my various parts and where we will delve into the subsequent steps to work criticals and also the success of study. Step 4 is data processing. Before process, applying any model data set underwent through the data processing to ensure it was clean, structured, and ready for analysis. These steps handling the missing the value to maintain the data integrity, one hot encoding in journals to convert the categorical data into the format of suitable machine learning models, and then next converting the timestamp into the time based features to capture the temporal pattern in user behavior, transforming users and movie IDs into the numerical embedding and facilitate the efficient processing. These processing steps are essential to prepare the data in effective trainings for both collaborative filters and deep learning model. Matrix factorizations. Next, we will be employed. Matrix factorizations are widely used techniques for or the recommendation system. This method decomposes the user items interactions matrix and latent factors that present to user preferences and item characteristics. By identifying these underlying patterns, the model generated personalized recommendation. To ensure the optimal performance, the model was fine-tuned and validated using across validations, resulting the high accuracy in predicting user ratings and auto-encoded. We also, step number 6, we also explored the autoencoders and deep learning approach to learn non-linear relationship bit by the compressing and reconstructing the user preferences. This technique captures complex pattern in data and enhancing the recommendation accuracy. And the autoencoders model was trained on the dataset to identify the integrate user items, interactions, and provide the robust predictions and significance, improving overall system performance. 7, step number 7, hybrid collaborative filters. Finally, we implemented hybrid collaborative filters, which combines the collaborative filters with the content based features such as genres. This approach addresses the cold state problems by leveraging with both user or behavior and item metadata. By integrating the multiple data sources, the hybrid models generate well-rounded and diverse recommendation system, and enhancing the personalizations and system robustness. Continuing to research methodology, let's now to discuss about the final stage of the model evaluation. To ensure that model analysis in this analysis we examine that distribution of movie ratings and the prevalence of the various genres with this data set. These insights are essential for understanding user behavior and challenging associated with the developing robust recommendation system. Analysis of rating distributions and the data sets reveal the notable skew into the user rating with significant concentrations of rating around the higher end of the scale. The pattern suggests as a positive user bias, where the users are more inclined to rate movies they enjoy, such as imbalance possesses challenges of the recommendations algorithm, particularly inaccurately predicting the negative user preferences and identifying the less popular content and analyze the genres distribution. Regarding the genres distribution, the data indicates a substantial disparity in the representations of different genres. Specifically, genres such as drama and comedy dominate the dataset, while others, including film noir and musicals, are significantly underrepresented. Uh, this imbalance maybe leads to biased performance in the recommendation system, where algorithms are more effective for more popular genres but struggles to the accurate recommendations to the need to the nice and less represented categories. Conclusion: the these findings underscore the importance of addressing the imbalance data imbalance uh, and users bias in the developing developing the recommendation system. Future works should focus on strategies and mitigate these challenges, ensuring that equitable performance across all genres and improving the predictions diverse and user preferences. In this section, we will delve into the distribution of rating per movie and distribution moving per rating and users. Understanding these conditions and these distributions is crucial in identifying the potential biases and challenges in the recommendation system. Analyze the ratings in movie by per movie. The digital exhibit a long tail distributions in the number of rating per movie. A majority of movies receive a limited number of ratings, while a small subset of movie accumulates a significant higher number of ratings. This popular bias can lead to recommendation algorithm favoring demonstrating mainstream titles, thereby reducing the visibility of niche and less popular content, such as a bias can limit a diversity of the recommendation system and hinder the diversity of unique underrepresented movie. An analysis of report by per user, similarly, the distribution of rating per user is highly skewed. Uh, and a small number of rating, while major minority of users are provide a large volume of rating. This really reliance of on a small group of highly active users can be introduced bias into the recommendation process. Additionally, it is sparsity of the ratings from the majority of users poses challenges and and for the collaborative filters method, which is relying on the users item and interactions to generate their recommendations and recommendation. So conclusions of these findings highlights to represent to presence of the popularity bias date and data disparity sparsity in the data set, which can significantly impact on the performance and fairness of the recommendation system. Addressing these issues is essential for developing the more balanced and inclusive recommendations algorithm that can cater a diverse range of the user preferences and movie genres. So analysis of examining the average rating, uh, uh, different genres with temporal trends into the average rating. These insights provide a valuable information about the user preferences and the evaluations of the content quality and over the time. And analysis average rating per genres. This data sets reveal the significant variations in the average of ratings across the different genres. Certainly, um, genres such as film noir, war, documentary consistently receive the higher average ratings, indicating the strong user appreciation. And these for these categories, genres like drama, like mysteries, and also perform well, but reflecting to their popularity and user satisfaction. In the contrast, genres such as horror and undefined um, categories are tend to have lower average ratings, and suggesting the more varieties of the user receptions and potentially less consistent content into the quality. Analysis of a temporal trend in average ratings uh, examine that the average rating of over the year the mid of 1990s and around 2010, the they are marked by peak to average limit of average ratings indicate that period of high satisfactions and potential um, and higher content quality. And conversely, the early 2000s shows the decline the average rating. However, the recent year demonstrated an upward trend, suggestions improving user satisfaction and evolving the content quality. And this trends may reflect the changes production and standard user expectations or the availability of diverse and high quality content. The conclusion of this exploring data has finding the underscore the importance of genre specific analysis and the temporal trends of understanding the user preferences, and these patterns can help to refining the recommendation algorithm in a better align and with respect to the user expectations and improve overall user experiences. Next, we have our results and evaluations where we are doing the presenting the SVD based matrix factorizations, and this performance matrix provides the insight into the model accuracy and relevance of the product predicting user ratings and genre recommendation. Result summary: uh, the SVD based matrix factorizations models demonstrated the high accuracy into the predictions user rating. Achieving the root mean square is 0.78% and the mean square absolute square is 0.59. Uh, these metrics indicate that the model predictions are closely aligned and actual user preferences, showcasing its effectiveness in the capturing user items and interactions. Recommendations relevance: the model's recommendations relevance was evaluated using precision 10, recall at 10, precision at 10 score was 81% in indicating that top 10 recommendations and relevant into the user, and recall was in 53%, where which is showing that It is all relevant items, and these results highlight the model's strong precision in delivering and relevant recommendations through their room and improvement into the recall. Uh, to ensure that more if comprehensive coverage of relevant items and strength and improvement area, uh, strength and improvement area is basically the model of effectiveness and balance accuracy and relevance, and it is making us the robust personalization recommendation. However, there are some potentials to enhance it and recall it without compromising the precision. Improving the recall of word ensure that would ensure that the higher proportion of relevant items are included in the recommendations. Here, uh, providing users with more comprehensive and satisfying experiences. The conclusion is overall SVD matrix factorization model perform well in the terms of accuracy and relevancy. Future for work and focus optimizing recalls and further enhance the model's ability and deliver comprehensive and personalized recommendations. In these sections, also we will be present the performance analysis of hybrid recommendations model, focusing on the key evaluation matrices and prediction accuracy and optimization opportunities. This hybrid model achieved the root mean square is 3.42 and mean square was 3.3. Mean absolute error was 3.3, and indicating that model is capable making the functional room of improvement in due to the challenge, and such as the data sparsity and variability into the user behavior, which can affect the model accuracy and reliability. To evaluate the relevance of recommendations, we analyzed precision at recall at 10 metrics, where I found that precision was 84% and recall at 10 was 58%, which suggests that recommendation is highly relevant and recall is model effective and it is more retrieve the more relevant items, and there is some potential to improving the recall to capture their larger portion of relevant recommendations, and these findings and highlights the model strength is delivering the precise recommendation, but also suggests that need to enhance their improve the recall performance. A key strength of this model is its ability to integrate both the collaborative filters and content-based recommendation technique, ensuring a balance between the personalization and diversity. However, the relatively high error rate indicates area further optimization. Future improvements could focus on adjusting the weighting and of the different recommendations and components, incorporating the contextual features and defining the model learning parameters to enhance the prediction accuracy. In conclusion, we while a hybrid model demonstrating promising the performance in the delivering personalized recommendation with high precision, further optimization its strategy are necessarily to improve the accuracy and recall. By addressing these limitations, the model can be achieved but better overall effectiveness in the recommendations, recommending relevant items while maintaining the balance between the diversity and personalization. Uh, these sections also we have some prediction accuracies and also some autoencoder based recommendation model, and focusing on the predictions accuracy, recommendations relevance, and associated strengths and challenges. The model achieved a root mean square errors which is 3.02 and mean square absolute error is 2.803, which is indicating the moderate accuracy, while model effectiveness captured general trend in the data, and its struggle making precise detailed predictions due to the sparse user item interactions. And this limitation suggests that while the models can be infer broad in pattern, and its performance could be enhanced by the incorporating the richer contextual information or additional data sources. And to assess these recommendations relevance, we analyze precision at 10 and precision at recall at 10 score, where precision was 53% and recall was 16%. That indicates the limited ability to uh, cover, and also the relevant items are highlighting inherent precision recall trade-off. And this suggests that while model delivers relevant recommendation and it fails to retrieve a broader set of relevant items and potentially and limited user engagement and satisfaction. And the key strength of this autoencoder, the model, is ability to leverage deep learning techniques to identifying the complex pattern to the data and enhancing this and capacity to making the personalized recommendations. However, one of its major challenge of sensitivity to sparse the data, which can load suboptimal learning and degraded performance. Additionally, balancing high precision of broader recall remain a challenge, and improving one often come at the cost of the others. These limitations indicate the further refinement and such as the data augmentation and techniques, hybrid modeling approach, and improve the loss of functions could enhance the model's overall effectiveness. In conclusion, while autoencoder models are demonstrated moderate and prediction accuracy and high performance is too low, um, low recall and sensitivity is sparse data, and suggest area of improvement and future enhancement should focus on the optimizing the recall without any significant compromising in precision, thereby ensuring that more comprehensive and recommendation coverage should be take place. So, conclusion of the study here is summarize the key findings and takeaway. For the evaluation of the different recommendations models highlights their strength and limitations, and area of improvements and metric factorization demonstrated high accuracy with relevant relative low RMSE and MAE effectively captures user item interactions. However, autoencoders, while showing the promise to learning something complex pattern, and exhibit higher errors when and dealing with this sparse data set. The hybrid collaborative filters model successfully balanced and accuracy of the integrating both collaborative and content based filters, offering the more adaptive and robust techniques and recommendations approach. And major challenge was observed across all the models was the cold start problems, and which arises the limited interactions of the data for the new users and item. For both metric factorizations and autoencoders are relied on heavily historical data, and making them the susceptible and to the sparsity and issues. So hybrid model attempt to mitigate the limitations by incorporating content metadata, but extreme sparsity still posed a significant challenge, and emphasizing the, the needs of the future enhancement in handling the cold start scenario. The scalability of perspective matrix factorization showcased strong scalabilities and efficiency when applied to large data set, while autoencoder handle the high demonstrate high dimensional data well with the required greater computational resources, making a less efficient or in real time application. And hybrid model effectively scaled across the multiple data sources but incur higher computation overhead, and highlighting this necessary trade-off between the efficiency and performance in the recommendation system. Comparing the strength and limitations of these models, matrix factorizations was found to be simple and accurate, but struggled with the cold start and content-based nonsense. Autoencoder also provided flexible in capturing the complex pattern yet faced challenges in the data sparsity and high computation demand. In the contrast, hybrid collaborative filters model provided proved that to be the most versatile and balanced accuracy and diversity and scalability. While effective at addressing a cold start issue, however, it requires careful tunings and additionally computation resources to optimize their performance. In summary, while you while each model has its distinct advantages and drawbacks, future work should focus in enhancing the hybrid approaches, integrating the contextual informations and improving the computational efficiency to develop more robust, scalable, and personalized recommendation system. So there are some future scopes as I mentioned. So in the research, while the study has provided valuable insights, there were several areas for the explorations and improvement. This future's development of recommendation system should focus on several key areas to enhance their accuracy and efficiency and user engagement. One difficult direction is enhancing the diversity and novelty in the recommendations is implementing diversity aware optimization technique or multi-objective framework that can be ensured that recommendations were varied and unique. Balancing the relevance with the exploration, this will help to improve the user engagement by reducing the redundancy in the recommendations and providing the new diverse suggestions. Another important factor is incorporating the temporary dynamic into the model as a user to to preference the item popularity evolve over time, and integrating a time aware of or a sequential technique can help to capture these shifting pattern. The model that can be adapted to temporal changes will be improve the relevance and timeline of recommendation, ensuring that users receive the content aligned with their latest interest. As dataset continue to grow and improve their scalability and efficiency and become crucial, and futures advancement should be focused into the developing a more efficient algorithm and and architectures of leveraging the data distributed computations and parallelization to handle the high dimensional data. This particularly important for deep learning based model like autoencoder, which require significant computations resources, and optimizing the processes can be reduce the computation cost while maintaining the high recommendation performance. Alongside uh, challenges in recommendation system is addressing the cold store problem, uh, which occurs when there is limited interaction data of our new users or time items. Future research should be explore the use of additional data sources such as user demographics and item item descriptions to make a more informed prediction. And additionally, techniques such as transfer learning and zero shot learning can help to predict the user preference in a sparse data scenario, and making the recommendation more effective and even more with the minimal interaction of history. And in conclusion, the future advancement in the recommendation system should be prioritized into the diversity and temporal adaptability and scalability, and improve the handling of the cold start issues. By integrating these improvement, next generations models will offer more dynamic, efficient, and personalized recommendations, enhancing overall the user experiences. In the references in the study, we have extensively reviewed and cited various research works to support our finding and methodologies. Over our research reference, our references includes to key publications of the collaborative filtering, a hybrid recommendation model, and deep learning technique. For recommendation system, notably studies on matrix factorizations, autoencoder, and hybrid model have provided the critical insights into the challenges and advancement in the recommendation system. Several work such as those published in triple IT transaction, triple IEEE transaction, ACM transactions, and applied science offer foundations of our approach by addressing their scalability and cold start issues, and optimizations techniques in the recommendation system. Additionally, conference proceeding from ICIC, CS, and other international venues provide insight into the latest innovations and comparative analysis of recommendation algorithm. These references serve as a cornerstone for our research, and ensuring that our findings align with the existing literatures, and while also contributing the new perspective to field. Thank you and have a nice day.